Top 30 Cloud Architect Interview Questions and Answers. Preparing for a Cloud Architect interview requires more than memorizing cloud services. Interviewers want to understand how you approach scalability, security, reliability, networking, migration, automation, cost optimization, and business requirements. In this guide, you will find 30 important Cloud Architect interview questions with practical answers designed to help you respond confidently. Use these answers as a foundation, then personalize them with examples from your projects, technical experience, and architectural decisions to make your responses more credible and impactful. Preparation helps you explain trade-offs and handle scenario-based questions calmly during interviews. What does a cloud architect do?
A cloud architect designs scalable, secure, reliable, and cost-effective cloud environments aligned with business goals. The role involves selecting cloud services, defining architecture patterns, planning migrations, establishing security controls, and guiding engineering teams. A strong cloud architect also considers performance, availability, disaster recovery, governance, and operational efficiency. The architect communicates technical decisions clearly and ensures solutions remain flexible as organizational requirements evolve across changing business environments.
How do you approach designing a cloud architecture?
I begin by understanding business objectives, workloads, compliance requirements, budget, performance expectations, and existing infrastructure. Then I assess application dependencies, data flows, security needs, and operational constraints. Based on that assessment, I compare suitable cloud services and architectural patterns. Finally, I document the proposed architecture, identify risks, estimate costs, validate assumptions through prototypes, and review the design with stakeholders before implementation begins and approval is granted.
Which cloud platforms have you worked with?
I have experience working with major cloud concepts including compute, storage, networking, databases, identity, monitoring, automation, and security. Depending on organizational requirements, I can design solutions using AWS, Microsoft Azure, or Google Cloud. My approach focuses on selecting managed services where appropriate, reducing unnecessary complexity, and creating architectures that balance reliability, performance, security, scalability, and cost, while remaining maintainable for engineering teams throughout implementation and operations across changing environments.
How do you design highly available cloud systems?
I design for failure rather than assuming infrastructure will always work. I use multiple availability zones or regions when business requirements justify them, deploy redundant components, implement health checks, and automate recovery processes. I also establish backups, disaster recovery procedures, monitoring, and tested recovery objectives. Reliability should be measurable through availability targets, recovery time objectives, recovery point objectives, and regular resilience testing under realistic failure scenarios across critical workloads.
How do you plan disaster recovery in the cloud?
I start with the organization's recovery time objective and recovery point objective because these determine how quickly services must return and how much data loss is acceptable. Then I evaluate backup, replication, multi-zone, and multi-region strategies. I consider application dependencies, data consistency, cost, and operational complexity. Finally, I document recovery procedures and conduct regular disaster recovery tests to verify that the design works as expected consistently across critical systems.
How do you ensure cloud security?
Cloud security should be integrated into architecture from the beginning rather than added later. I apply least privilege access, strong identity controls, encryption, network segmentation, secure configurations, logging, monitoring, vulnerability management, and continuous compliance checks. I also separate environments, protect secrets, automate security policies, and review architecture against organizational standards. Security decisions should address people, processes, applications, infrastructure, and data throughout the complete solution lifecycle across changing requirements.
How do you implement least privilege access?
I use the principle of least privilege, granting users and workloads only the permissions they genuinely require. I implement role-based access, centralized identity management, multi-factor authentication, temporary credentials, and regular access reviews. Service accounts receive narrowly scoped permissions, while privileged activities are monitored and logged. I also separate duties where appropriate and automate permission management to reduce human error and prevent excessive access from becoming a security risk across users and workloads.
How would you approach a cloud migration?
I approach cloud migration by first discovering applications, infrastructure, dependencies, data, performance requirements, and business priorities. Then I classify workloads using strategies such as rehost, replatform, refactor, retire, or retain. I prioritize low-risk opportunities for early learning, establish migration waves, validate connectivity and security, and define rollback plans. Continuous testing, monitoring, stakeholder communication, and post-migration optimization help ensure a controlled and successful transition with minimal business disruption.
How do you optimize cloud costs?
I use cost optimization as a continuous architectural practice, not a one-time exercise. I right-size resources, select appropriate pricing models, use auto-scaling, eliminate unused capacity, apply storage lifecycle policies, and consider reserved or committed pricing where workloads are predictable. I also establish budgets, cost alerts, tagging standards, and ownership reporting. The goal is to reduce waste without compromising security, reliability, performance, or important business requirements while protecting business value.
How do you choose the right cloud service?
I choose between services by starting with requirements rather than personal preference. I compare functionality, reliability, performance, security, integration, operational effort, scalability, regional availability, vendor dependencies, and total cost. Managed services are often valuable because they reduce operational overhead, but they may introduce limitations or lock-in. I document trade-offs clearly, test critical assumptions, and select the service that best supports long-term business and technical objectives across the entire organization.
How do you design a scalable cloud architecture?
I design scalable architectures using horizontal scaling, stateless application components, load balancing, caching, asynchronous processing, and managed services where appropriate. I identify bottlenecks through performance testing and monitoring, then scale individual components independently when possible. Auto-scaling policies should respond to meaningful metrics rather than arbitrary thresholds. The architecture must also account for database scaling, traffic patterns, capacity limits, and predictable growth so performance remains stable over time as requirements evolve.
How do you design cloud networking?
I treat networking as a foundational architectural layer. I design virtual networks with appropriate subnets, routing, security controls, private connectivity, DNS, and segmentation. Public-facing components are isolated from sensitive internal resources, while private services communicate through controlled paths. I also consider hybrid connectivity, latency, bandwidth, resilience, and address management. Good network architecture should support security, availability, troubleshooting, and future expansion without unnecessary complexity across changing traffic conditions.
What is infrastructure as code, and why is it important?
I use infrastructure as code to make cloud environments consistent, repeatable, reviewable, and easier to manage. Tools such as Terraform, CloudFormation, or Bicep can define infrastructure through version-controlled configurations. Changes can follow code review, testing, automated deployment, and approval processes. This reduces configuration drift and manual errors while improving disaster recovery. I also organize reusable modules and establish standards so teams can provision environments efficiently without creating unnecessary operational burden.
How do you implement cloud monitoring and observability?
I design observability around metrics, logs, traces, alerts, dashboards, and meaningful service-level objectives. Monitoring should cover infrastructure health, application behavior, security events, dependencies, and user experience. Alerts need clear thresholds and actionable ownership rather than generating unnecessary noise. Centralized logging and distributed tracing are especially important for microservices. I also use monitoring data to identify capacity problems, performance degradation, failures, and opportunities for continuous improvement for faster issue resolution.
When would you use containers and Kubernetes?
I use containers when applications benefit from consistent packaging, portability, rapid deployment, or independent scaling. Kubernetes can provide orchestration, service discovery, scheduling, rolling deployments, and automated recovery, but it also introduces operational complexity. I would not choose Kubernetes automatically. I first evaluate workload requirements and organizational capabilities, then determine whether managed container platforms or simpler services provide better value, reliability, security, and maintainability for the organization across development and production environments.
How do you design microservices architecture?
For microservices, I focus on clear service boundaries, independent deployment, resilient communication, observability, security, and data ownership. Services should avoid unnecessary coupling and communicate through well-defined APIs or asynchronous messaging where appropriate. I also plan for retries, timeouts, circuit breaking, idempotency, and failure isolation. The architecture should balance team autonomy with operational complexity, because microservices can create significant overhead when introduced without clear business or technical justification when teams and workloads expand.
How do you design a cloud data architecture?
I design data architectures by considering consistency, availability, latency, volume, access patterns, retention, compliance, and recovery requirements. I select relational, NoSQL, object, analytical, or specialized databases according to workload characteristics. I also define encryption, backup, replication, lifecycle management, and access controls. Data ownership and movement should be documented clearly because poor data architecture can create performance problems, security exposure, unnecessary costs, and difficult operational dependencies throughout the complete data lifecycle.
When would you recommend a multi-cloud strategy?
I evaluate multi-cloud when there is a clear business reason, such as regulatory requirements, specialized capabilities, resilience objectives, or strategic risk management. I recognize that multi-cloud can increase networking complexity, operational effort, skill requirements, and costs. I avoid adopting it simply to prevent vendor lock-in. If multi-cloud is justified, I standardize governance, identity, observability, automation, and architecture patterns, while accepting that services will not always be identical across all supported cloud environments.
How do you minimize cloud vendor lock-in?
I reduce vendor lock-in by separating business logic from provider-specific components where practical, using open standards, containers, portable data formats, and abstraction layers when they provide genuine value. However, I do not avoid managed services automatically because they can significantly improve productivity and reliability. I document dependencies and migration implications, then make deliberate trade-offs between portability, operational simplicity, performance, cost, and access to valuable cloud-native capabilities for future architectural flexibility.
How do you explain technical architecture to business stakeholders?
When discussing architecture with non-technical stakeholders, I focus on business outcomes rather than technical terminology. I explain how proposed decisions affect cost, risk, delivery speed, reliability, security, and customer experience. I use diagrams, simple examples, and measurable outcomes to communicate trade-offs. I also listen carefully to business concerns and confirm assumptions. Effective communication helps stakeholders make informed decisions and builds confidence in architectural recommendations across the organization.
How do you manage technical debt?
I manage technical debt by identifying its business impact, security implications, operational risks, and future maintenance costs. Not every outdated component requires immediate replacement. I prioritize debt that creates significant reliability, security, performance, or delivery problems. I document decisions, include remediation work in roadmaps, and encourage teams to address manageable debt continuously. The goal is sustainable architecture, rather than endlessly pursuing technical perfection without business value while preserving delivery speed.
What do you look for during an architecture review?
I approach architecture reviews by checking requirements, assumptions, security, reliability, scalability, performance, operations, cost, compliance, and disaster recovery. I review diagrams, data flows, dependencies, failure scenarios, and service limits. I ask whether the proposed design solves the actual business problem and whether the organization can operate it effectively. Reviews should produce clear decisions, risks, actions, and ownership rather than becoming theoretical discussions without measurable outcomes across different projects and teams.
What architectural principles do you follow?
I use architectural principles to guide decisions consistently. Common principles include security by design, least privilege, automation, loose coupling, managed services where appropriate, observability, resilience, and cost awareness. Principles should support business objectives rather than become rigid rules. I document important decisions through architecture decision records, explaining the context, options, chosen approach, and consequences. This creates transparency and helps future teams understand why decisions were made before approving major implementation changes.
What is the role of an API gateway?
API gateways provide a controlled entry point for services and can support authentication, authorization, routing, throttling, monitoring, transformation, and policy enforcement. I use them when centralized API management provides meaningful value. However, I avoid turning the gateway into a complex bottleneck or business logic layer. I also design for high availability, appropriate timeouts, rate limits, versioning, and observability so the gateway remains reliable as traffic grows across different projects and teams.
When would you use serverless architecture?
Serverless architecture can be valuable for event-driven workloads, variable traffic, rapid development, and applications where minimizing infrastructure management is important. It offers automatic scaling and usage-based pricing, but introduces considerations around execution limits, cold starts, observability, vendor-specific services, and application design. I evaluate workload characteristics carefully before choosing serverless. The best architecture depends on business requirements, operational capabilities, performance expectations, and long-term maintainability without unnecessary complexity or cost.
How do you handle cloud incidents?
I handle cloud incidents by first protecting customers and stabilizing affected services. I use documented incident response procedures, clear ownership, monitoring data, logs, and communication channels. After recovery, I conduct a blameless review to identify technical and process causes. Corrective actions should have owners and deadlines, and lessons should feed into architecture improvements, automation, testing, monitoring, and documentation. Strong incident management turns failures into opportunities for resilience while supporting reliable customer experiences.
How do you maintain cloud architecture documentation?
I manage architecture documentation using clear diagrams, decision records, standards, and operational guidance. Documentation should explain system boundaries, dependencies, data flows, security controls, recovery strategies, and important design decisions. I keep documents version controlled and update them when significant changes occur. Good documentation is concise enough to remain useful while detailed enough for engineers, operations teams, security specialists, and stakeholders to understand the architecture accurately across every stage of incident management.
How do you prepare for a cloud architect interview?
I prepare for cloud architecture interviews by reviewing core cloud services, networking, security, databases, scalability, reliability, migration, automation, and cost optimization. I also practice explaining architectural trade-offs using real scenarios. Strong answers demonstrate structured thinking rather than simply listing services. I discuss requirements first, compare options, identify risks, and explain why a selected design fits the situation. This approach shows both technical knowledge and practical architectural judgment, so teams can work confidently.
How do you balance innovation with architectural stability?
I balance innovation with proven architectural patterns by evaluating the maturity, risk, cost, and business value of new technologies. I avoid adopting technology simply because it is popular. Instead, I use prototypes or proofs of concept to validate performance, integration, security, and operational requirements. If the technology provides meaningful benefits, I define standards and adoption guidance. This approach encourages innovation while protecting reliability, maintainability, and long-term business objectives across future projects.
How would you describe your leadership style as a cloud architect?
My leadership style is collaborative and evidence-based. I involve engineers, security teams, operations, product owners, and business stakeholders when decisions affect their responsibilities. I encourage healthy technical debate, document trade-offs, and make decisions when sufficient information is available. I also mentor engineers and promote automation, shared standards, and continuous learning. A cloud architect should provide direction while enabling teams to deliver solutions independently and confidently while supporting organizational growth. A successful cloud architect interview answer should demonstrate both technical depth and practical decision-making. Focus on explaining why you would choose an architecture, not simply naming cloud services. Discuss security, scalability, reliability, cost, performance, operations, and business impact whenever relevant. Practice these 30 questions aloud and adapt each answer to your experience. With structured preparation, clear communication, and strong architectural reasoning, you can approach your cloud architect interview with greater confidence and professionalism. Remember to use examples, measurable results, and lessons learned whenever possible, because they make your answers convincing.